Okay. Did we do the sixth sum yesterday? No?
No, sir.
Okay, we'll discuss the sixth one then. So we have to look at this number line and answer the following questions. So the first one is, state which points are equidistant from B. What do you mean by equidistant? Yes, what is the meaning of equidistant?
They are equal distance from point B.
Correct. You have to find the points which are at equal distance from point B. So can you name them? Okay, we will find the distance and do it. So let's see first distance between B and C. Can you tell me what will be the distance between B and C? How to do the subtraction?
4 minus 2.
Correct. 4 minus 2, that is 2. Okay. Distance between B and A. What will this be?
2 minus 0.
2 minus 0, which is 2. So is A and C equidistant from point B? Yes.
Yes.
So therefore, A and C are equidistant from point B. Are there any more points that are equidistant from point B?
So
How about
point P and D.
point D and
P
which
and
one?
D.
Which was the first one?
P and
P and
yes.
and
D.
D. P and D you're saying. Okay, let's see. Let's check it. So let's find distance. First you said P, na? So let's find distance BP. Okay. How much is distance BP? Can you tell me?
Minus 2. Minus 2.
No. 2 minus 2. That is 4. And you said D, right?
D,
So
yeah.
distance BD. Okay. Can you say distance BD? It will be 6.
6 minus 2.
Okay. 6 minus 2, which is 4. Correct. So we can, here from here, we can say that, therefore, P and D are equidistant from B. Is there any more? You can try counting the units also.
I don't think so.
Okay, yeah, that's it. This is, if there would have been a point here, then we would get one more possibility, but there is no point here. So it's okay. Oh, write this down.
Done, sir.
Can you do the second one? Write pair of points equidistant from Q.
Then actually you are stupid.
Done, sir.
What is the answer? Which are the points?
U and L are equidistant, and P and R are equidistant.
Correct. Okay. Do the third one also. You just have to find the distance distance UV, distance PC, VB, and UL.
So done, sir.
What is distance UV?
10.
Okay. Distance PC
6.
and VB
3.
and UL.
2.
How to UL? L is -3 and U is -5. So ignore the negative signs. So it is 3 and 5. So it should be 2, right? Did you say 2? 2.
I said
Yeah.
2.
Yeah, then it's correct. Okay. Okay. Let's understand now statements. What are statements in geometry? Now, under statements, first thing what you have is a conditional statement. Now, what is a conditional statement? See, a statement which can be written in the form of if then, means if something, then something. So that is called we are putting a condition. If this happens, then that will happen. So it is called an if then statement. So such form are called as conditional statement. The part of the statement following if is called as antecedent, and the part following then is called consequent. That means if after if what part is there, that is called as antecedent, and after then what part is there, that is called as consequent. For example, look at this statement. The diagonals of a rhombus are perpendicular to, okay, don't look at that, look at this. If the given quadrilateral is a rhombus, then its diagonal are perpendicular to each other. Look at this example. This is an example of a conditional statement. So see, if the given quadrilateral is a rhombus, if it is a rhombus, then diagonals are perpendicular bisectors of each other. So see, this is a very typical example of if-then statement. Okay, this is an example of if-then statement. If something is happening, then along with that something else happens. So if something, then something. Now, the part following the if, that is this part, that means the part after if, is called as antecedent. Okay, the part following the if is called as antecedent, and the part following the then, that means after then, whatever part is there, that part of the statement is called as consequence. So basically there is a condition, we are putting a condition. That means for that quadrilateral to be a for the perpendicular of for the diagonals of the rhombus to be perpendicular, the condition is the quadrilateral should be a rhombus. So usually antecedent are called as conditions, and the consequence, so this would be the condition, and the consequence usually is also called as a result. Okay, so this was a very good example of if-then statement. Now, look at this statement here, what it says that if the antecedent and consequent in a given conditional statement is interchanged, okay, if you interchange it, that means in place of the antecedent, you write the consequent, and in place of the consequent, you write the antecedent, then the resulting statement or the new statement that is formed will be called as a converse of the given statement. Okay, converse is usually opposite or other way around. So the statement that we just now wrote, if you see this is its converse. So if a quadrilateral is a rhombus, then its diagonal are perpendicular bisectors of each other. If you see, the first statement is the original statement. If the given quadrilateral is a rhombus, then its diagonals are perpendicular to each other. So I'll mark in blue. This is the antecedent. Okay, the blue is the antecedent and the green is the consequence. So this is your original conditional statement. Now, if you interchange the antecedent, and the consequence and make a new sentence, okay, grammatically correct sentence. So if I interchange the antecedent and the consequence, then a new sentence is formed. So if, now this I'm bringing in the form, it's like basically changing the subject and predicate. So if the diagonals of a quadrilateral are perpendicular bisectors of each other, then it is a rhombus. So if you notice here, this is the new antecedent and this is your consequence. So if you interchange, then the new statement that is formed is called as the converse of the original statement. Did you understand what is converse?
Yes, sir.
Okay. Now look at this example here. If a number is prime, then it is even or odd. Now this is the original conditional statement. If it is prime, then even or odd. Now when you want to find a converse, the converse will be if a number, you're just interchange. If a number is even or odd, then it is a prime. Okay. Now if you check the whether the statement, now note one thing, that a statement always have two values. It can either be true or false. It cannot be both. Okay, a statement can either be true or it can be false, but it cannot be both. So if you see, the first conditional statement is true. That means if a number is prime, then it is either even or odd. That is true. But the converse, is the converse true? That means if a number is even or odd, then it is prime. Is it true? Does it ever happen? If a number is even or odd, then it is a prime number. Is it true?
Yes, sir.
It is true?
Only one number.
Only one.
One even number.
Huh.
Is
But is it true for all numbers? Let's take, for example, I'll take an even number 6. Is 6 prime?
no, sir.
No, 6 is not prime. I'll take an odd number, say, I'll take an odd number 9. Is 9 prime?
No, sir.
No. So can I say that this statement is true? If a number is even or odd, then it is a prime number. Is it true? No, it is not
Yes.
true. So that only they have said the conditional statement is true, but the converse is false. Okay, so not necessary that if the conditional statement, if the original conditional statement is true, it is not necessary that the converse also will be true. Converse can be false. Or if a conditional statement is false, then its converse can be true. Okay, is this clear? Conditional statement and its converse.
Yes, sir.
Okay. Now, where are these statements, conditional statements, where they are used? That is a question. Now, usually conditional statements are used in proving theorems, in the statement of theorems. They are used in properties, the statements, if then conditional statement, and the converse, where it is used. So see, I'll read out this for you. So this says, so in this standard, we are going to look at the subject of geometry with different point of view, which was originated by Greek mathematician Euclid. Now, Euclid, this is his picture which is given in your textbook. He was a very famous Greek mathematician, and a lot of your geometry, what you study, and even higher, the higher mathematics, which you will study later on, most of them were postulated or were given by Euclid. If you know your simple division, the long division method that you do, that is also the actual name of that division is called as Euclidean algorithm, which was found by Euclid. The proper long division that you do, quotient is equal to dividend is equal to quotient into divisor plus remainder. That when we do by division, that is called as a Euclidean algorithm. So that also was given by Euclid. So he has given a lot of contribution in the field of mathematics. And in your later point of time, when you learn higher mathematics, also you will come across various definitions and theorems which was proved by Euclid. So here there are some examples given which was found by Euclid. So he gathered the knowledge of geometry prevailing at his time and streamed it. He looked for granting some self-evident geometrical statements, okay, which were accepted by and all called them postulates. Now, what are postulates? Postulates are those statements which are true without any proof. Okay, postulates are those now usually in maths, whenever we uh, say a statement, we have to prove that statement. Okay, there has to be a strong and concrete proof of that statement. But then there are certain properties or certain theorems which we understand it or which is taken for granted. Okay, that means we it does not have a formal proof. Those statements are called as postulates. Let's see, there are some examples. He showed that the basis of postulates are more properties and can be proved logically. So logically it can be proved, but it won't have a strong and concrete proof. So such statements are called postulates. Now, these are the examples of postulates which was given by Euclid. And the first one, if you see, there are infinite line passing through a point. That means through one point. Okay, through one point, how many lines can you pass through it? And for that, the answer is infinite. So suppose I'll show you. So suppose you have a point. Through this point, how many lines can you pass? So if you see, this is 1, 2, 3, 4. Can I pass more lines through this point?
Yes, sir.
Yes, so the answer is infinite. Now this we cannot prove mathematically. So this is, but this logically, if you see, it is correct. So this is a postulate. The first statement, if you see, it is a postulate. There are infinite lines passing through a point. If you see the second one, there is one and only one line passing through 2 points. Okay, so if you have 2 points, so 1 point here and 1 point here, through 2 points, you can pass one and only one line only. Okay, through 2 points, you can pass one and only one line, not more than that. Now, this also we cannot have a proper proof for it, but logically, yes. So there are so many other examples, and these are all called postulates. So some of these postulates can be verified by activities.
Oh, sure,
Yeah.
the meeting is going to end in 1 minute.
Yeah, yes.
So, so you join.
Yeah. Rejoin.